Alright, so like I was saying, I won't even fully do the first one. The first question is like this, isn't it? Yeah. But if you remember last time, I showed you how to rewrite this by using compound angles. I showed you how to rewrite it as something like this. A sine, I don't know, px plus q or something like that. Do you remember I showed you this? Like what was it? It wasn't the double angles, it was the compound angles. It was maybe 2 lessons ago? Yes. Yeah, it was on page 42, question 9. I showed you how to bring these together. But you know how to solve these ones, because where did these ones come from? Where? You saw this in semester 1, didn't you? And besides which, even if you didn't know that, all you would have to do here is divide everything by cos x. So sin x divided by cos x, what's that? It's tan x. And then cos divided by cos is gone. So you can get tan x equals minus b over a. And you know how to solve that one. The only thing I need to be careful about if I do it this way is what? Yes, you need to consider cos x not 0, which if you recall, you may be excluding some answers. You need to check. Okay? But I mean, we've talked about this in a great deal. So much so I'm not even going to do it, because I've done it in semester 1 and semester 2. More difficult and more interesting is this type, which I think is number 5 maybe, which is the example I'm going to do for you. Cos 5x plus cos x equals 0. Is that number 5? Yeah, it is. Now that's tricky. But why is it tricky? What's the problem here? What's the problem here? Problem? No problem?
5.
Yes. Because of the 5x. They're 2 different angles, which means I can't really put them together. But I could change 5x into a compound angle, couldn't I? So I could say cos 5x, I could say is cos 3x plus 2x. Yeah? So I could change this into cos 3x plus 2x plus cos x equals 0. Now before I do that, let's just see what's going to happen. So what rule would I need here? I need the cos A plus B rule. So I get cos A, so I get cos 3x, cos 2x plus, minus sin 3x, sin 2x plus cos x. And the problem has gotten worse, because now instead of having 5x and x, what would I have? I'd have sine as well, and 2x, and 3x, and x. So this doesn't feel like the best way to go ahead. Any other ideas? Yeah, maybe I could try dividing, but again it's the same problem. See, we have to understand what the problem here is. And the problem is the 5x and the x. I need to make them more similar. So I shouldn't change 5x into 3x plus 2x, because that actually makes it worse. Instead, I should change the 5x and the x into something that look a bit more similar. So, for example, I could do this. Cos 3x plus 2x plus cos 3x minus 2x equals 0. Now, it's still compound angle, and it's still 3x plus 2x. But I also changed the x as well into 3x minus 2x. This is to make them look more similar. so that when I use my compound angle rule, I can hope that more things will cancel, which they will. Because now this will be cos 3x cos 2x minus sine 3x sine 2x plus cos 3x cos 2x plus sine 3x sine 2x equals 0. And that's great. That's great because that one there cancels that one there. And it's even better because that is the same as that. Meaning I get this, 2 cos 3x cos 2x equals 0. Or I get cos 3x cos 2x equals 0.
What if the question is cosine 6x plus cosine x?
I was just about to talk about that. Yes. What if you had something weird? What if you had cos 7x and cos minus a quarter x? Or something like this. In other words, what's the general idea I'm doing here? Well, in general, what I'm doing is I'm saying a plus b equals 5x and a minus b equals x. This gave me a equals 3x and b equals 2x. So if we take Hong's example, what did you say, Hong? 7x, was it? Or 6x? 6x, and then a minus b equals x. So if I solve this, I'd get a, 2a equals 7x. So I'd get a is 7 over 2x. So then b would be, I need to make 5 over 2x. So I'd have cos 7 over 2x plus 5 over 2x to make the 6x, and then I'd have cos 7 over 2x minus 5 over 2x to make the cos x. Huh? What? Oh, everything else would be exactly the same, yeah. You'd still have the cos A plus b and the cos A minus b. Yeah, the only thing that would change in this example here is these numbers here. This would be 7 over 2, 5 over 2, 7 over 2, 5 over 2. If it was something like that. So, like I was saying, what you're really doing is a type of substitution. You're calling this here a plus b, and you're calling that there a minus b. Anyways, back to the question here. I can solve this because this has two possibilities. The first one is cos 3x equals 0, cos 2x equals 0, which we've done in semester 1 plenty of times. So first you do your cos inverse 0. Cos inverse 0 is pi over 2. That's the first answer. Pi over 2. And then you get the second answer, which is 2 pi minus the first answer, which is 3 pi over 2. But then don't forget you have to make extra answers. How do you make extra answers? By adding 2 pi. So you get 3x equals pi over 2, 3 pi over 2. Then I add 2 pi here. So that'd be 5 pi over 2, is it? 7 pi over 2, I hope. 11 pi over 2. No. 9 pi over 2, isn't it? And then here is 11 pi over 2. And then this one here, 2x will equal pi over 2, 3 pi over 2, 5 pi over 2, and then 7 pi over 2. And then I divide by the 2 and I divide by the 3 and I get all my answers here. My answers are pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, 11 pi over 6, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are the 10 answers for the original equation where x is between 0 and 2 pi. Did you write that down? Yeah. Where's Steve today? No? Siobhan? Hammer? Anyone else? He is in the other group. Don't worry, I didn't see him for physics, so he's probably not going to be in that group either. Okay. Yeah, that's all. So again, it's going to be using compound angles to simplify it, but the trick is you want to change the addition into multiplication. Whereas last time we changed the multiplication into addition. So it is useful to change it back into a multiplication, especially when you're trying to solve an equation, because now we can say this piece here equals 0 or this piece here equals 0. So I know I said last time it's often much better to change a... Try and guess your pin. No. If I keep guessing this, will I lock you out?
Yes.
Oh, nice.
What?
What?
It will delete everything in the phone.
Oh, you shouldn't have talked about that. Alright, yeah, that's all there is about that. Can I try and look here now? Is there anything else? No. Fractions are fine. We just need to simplify it first. Yeah, we'll come on to that actually. We've still got a bit more to do in trigonometry. We just do this. Alright, you can try those questions now. If you manage to do number 10 and 11, I'll be impressed. Just throw that out there.
Just the last
What we did in semester 1, Mohammed, which was divide everything by 2 and then divide everything by 3. It's the S step in EISF.